In this video, I will be discussing another branch of mathematics called differential equations. So what is a differential equation? A differential equation, which is in short called DE, is an equation which contains at least one derivative in its equation. And actually, there are two types of differential equations: the ordinary differential equation and the partial differential equation. The ordinary differential equation, which is called in short as ODE, is a differential equation whose unknown function depends only in one independent variable, while the partial differential equation is a differential equation whose unknown function depends on two or more independent variables. Now, this partial differential equation is most commonly referred to as the PDE. Now, whether it's an ODE or a PDE, you can identify the order of the differential equation. So what is the order of the differential equation? The order of a differential equation is the order of the highest derivative in the given equation, while the degree of a differential equation is the power to which the highest order derivative is raised when the differential coefficients are free from radicals and fractions. Now, I have here examples of differential equations. And you can recall from your previous calculus that whenever you say dy dx, this is represented as f prime of x, or sometimes it is represented as y prime. So whether it is written as y prime or f prime of x or dy dx, it means the same thing. So we have here examples of differential equation. Number 1, dy dx is equal to 3x squared minus sine x plus 2. This is an example of a differential equation because this equation involves one derivative. Now, what is the order of this differential equation? The order is the order of the highest derivative. And since this is a first derivative, the order is 1. And what is the degree of this differential equation? The degree is also 1. Why? Because the exponent where you can find dy dx is only 1. And you can see that there is no exponent here, but it is understood to have an exponent of 1. And what type of differential equation is this? This is called an ordinary differential equation because the variable y depends only in one independent variable x. Now, number 2, the second derivative of y with respect to x minus k squared times y plus 4, which is equal to 0, is an example of a differential equation. Why? Because it involves derivatives in it. And what is the order of the differential equation? The order is 2. So this is in the second order. Why? Because you can see here the second derivative of y with respect to x. But what is the degree of this differential equation? The degree is 1 because the exponent of the second derivative of y with respect to x is 1. And what type of differential equation is this? This is an ordinary differential equation. Number 3, the quantity x plus 3 times dy minus the quantity 1 minus 3x times dx is equal to 0. So this is another example of a differential equation. And what is the order of this differential equation? The order is 1 because it involves only first differentials. And what is the degree? The degree is also 1 here because the exponent to which the differentials are raised is 1. And what type of differential equation is this? This is an ordinary differential equation. Now, this is an example of a differential equation wherein it is written in a form of differentials. You see here only dy that is multiplied to x plus 3, and you see here only dx which is multiplied to the binomial 1 minus 3x. So number 4, y double prime plus 3y prime minus 6y is equal to 2. And what is the order of the differential equation? The order is 2. And what is the degree of this differential equation? The degree is also 1 here because this y double prime is being raised to an exponent of 1. And you cannot see an exponent of 1, but it is understood to have an exponent of 1. And this is another example of an ordinary differential equation. Number 5, k times y double prime, which is equal to the quantity y prime to the power of 2 plus 1, quantity raised to the exponent of 3 halves, is another example of a differential equation because it involves derivatives here. It involves second derivatives and first derivative. So what is the order of this differential equation? The order is 2 because that is the order of the highest derivative in this equation. So we have here y double prime. And what is the degree? The degree you might guess as 1, but actually the degree here is 2. Why? Because according to the definition that the degree of a differential equation is the power to which the highest order derivative is raised when the differential coefficients are free from radicals and fractions. Now, you see here differential coefficients, but this is raised to an exponent of 3 halves. So we need to free this one by squaring both sides of the equation so that this exponent 3 halves becomes only 3. And the left side will have an exponent of 2. That's why we have a degree of 2, because when you simplify by squaring both sides of the equation, the exponent of y double prime becomes 2. Now, this is another example of an ordinary differential equation. Number 6, the second partial derivative of z with respect to t minus 3 times the second partial derivative of y with respect to t plus the second partial derivative of z with respect to u is equal to 0. So what is the order of this differential equation? You see here that the highest order is 2 because all of them are in the second order. So the order of the differential equation is 2. But what is the degree of this differential equation? Since the exponent of the second partial derivatives are all 1, then therefore the degree of this differential equation is 1. And what type of differential equation is this? This is a partial differential equation because it involves partial derivatives. And how do we know that it's a partial derivatives? Because you are taking the partial derivative of z with respect to t here and also the second partial derivative of z with respect to u. So there are 2 independent variables here. You see the independent variables in the denominators here, the t and the u. So there are 2 independent variables. And since there are 2, then this is an example of a partial differential equation. Number 7, x times the fifth derivative of y with respect to x plus 4y times the third derivative of y with respect to x minus the sixth power of the derivative of y with respect to x is equal to 0. So what is the order of this differential equation? The order is 5. Why? Because we can see here the fifth derivative of y, and this is the highest among all the derivatives involved in this equation. But what is the degree of this differential equation? The degree of this differential equation is only 1, and it is not 6. Why? Although 6 is higher than 1, but this is not the highest derivative in this equation. The highest order derivative is this one. And since the exponent of this fifth derivative is only 1, then therefore this is of degree 1. And what type of differential equation is this? This is an ordinary differential equation. Number 8. The partial derivative of u with respect to t, which is equal to the second power of h times the quantity of the second partial derivative of u with respect to x plus the second partial derivative of u with respect to y is another example of a differential equation. And what is the order of this differential equation? The order is 2. Why? Because I see here second partial derivative. And what is the degree? The degree here is 1 because the exponent of your second partial derivative is only 1. And what type of differential equation is this? This is a partial differential equation, popularly known as the PDE, a partial differential equation. And lastly, what is a solution to an ordinary differential equation? A solution to an ordinary differential equation is another equation free of any derivatives or differentials, expressing the functional relationship between the dependent and the independent variables, and which when substituted into the equation reduces the equation to an identity, which means that it satisfies to the differential equation given. At this point, we will be discussing how to show a particular solution to a given differential equation. So we have B, show that y, which is equal to c sub 1 times e to the x plus c sub 2 times e to the negative 2x is a solution to the differential equation y double prime plus y prime, which is equal to 2y. So how do you show that this function y is a solution to this given differential equation? Now, looking at this differential equation, the given differential equation involves y double prime, y prime, and y. So, no problem with y because y is the solution to the given differential equation. But how do we get the other derivatives? We need to solve first the first derivative, and then after solving the first derivative, we need to solve for our second derivative. So, taking the derivative of this function, we have y prime, which is equal to c sub 1 e to the x times 1, because the derivative of e to the x is e to the x and multiplied by the derivative of x with respect to x, which is 1. And this is added to c sub 2 because c sub 2 is an arbitrary constant in this function, times e to the negative 2x times negative 2, because by the chain rule, we need to multiply e to the negative 2x by the derivative of the exponent, which is negative 2. Now, simplifying this one, we have y prime, which is equal to c sub 1 e to the x plus the negative 2 of c sub 2. So which means we have negative 2 c sub 2 e to the power negative 2x. So this is now our first derivative. And of course, because we have the first derivative, we can solve for our second derivative. So the second derivative of this function is taking the derivative of the first derivative. So this is equal to c sub 1 times e to the x times 1, because again, the derivative of e to the x is e to the x times the derivative of the exponent, which is 1. And then this will be subtracted by 2c sub 2 e to the power negative 2x times the negative 2. Because again, by the chain rule, we need to find the derivative of the exponent, negative 2x, and the derivative is negative 2. That is with respect to x. So simplifying this one, we have y double prime, which is equal to the first arbitrary constant c sub 1 times e to the x minus 2 times minus 2 becomes positive 4 c sub 2, another arbitrary constant in this solution, times e to the power negative 2x. So this is our second derivative here. Now that we have the y, the first derivative, and the second derivative, we can substitute all of this to the given differential equation. So substituting y prime, and y double prime, we have, so if we copy it here, that is y double prime plus y prime equals 2y. But our double prime is this, so we will write it here, c sub 1 e to the x plus 4 c sub 2 e to the power negative 2x plus the y prime. And our y prime is this one, plus c sub 1 e to the x minus 2 c sub 2 e to the power negative 2x, which is equal to 2y. And our y is this one. So times c sub 1 e to the x plus c sub 2 e to the power negative 2x there. And you can combine similar terms, this one and this one, which is 2c sub 1 e to the x. And also you can combine this one and this one. So 4 minus 2 is positive 2. So positive 2 c sub 2 e to the negative 2x, which is equal, if you distribute this 2 to this binomial. So 2 times c sub 1 e to the x is 2c sub 1 e to the x plus 2 times this one, that is 2c sub 2 e to the power negative 2x. And you can see that this is an identity here. Thus, we say and conclude that the function y, which is equal to c sub 1 e to the x plus c sub 2 e to the negative 2x, is a general solution to the given differential equation y double prime plus y prime, which is equal to 2y. Now let's proceed to this second example here. Show that y, which is equal to the arbitrary constant a times sine 5x plus another arbitrary constant b times cosine 5x is a solution to the differential equation, the second derivative of y with respect to x plus 25y equals 0. So how do you show that this y function is a solution to this differential equation? Now, looking at this differential equation, you see that it involves second derivative. So, of course, we need to solve first the first derivative. So, the first derivative of this a sine 5x is a times cosine 5x times 5, because the derivative of sine is cosine, and by the chain rule we need to multiply by the derivative of 5x, which is 5, and then we add that one to b times the derivative of cosine 5x, which is negative sine 5x, and by the chain rule again we need to multiply it by 5. So simplifying this one, this is equal to 5a cosine 5x minus 5b times sine 5x, and this is our first derivative. You can write y prime, or you may write dy dx, because these two can be used interchangeably. And of course, we need to solve the second derivative. So what is our second derivative? The second derivative is the derivative of our first derivative. So the derivative of 5a, because this is a constant, so we just copy, but the derivative of cosine 5x is negative sine 5x times 5, because by the chain rule we need to multiply by the derivative of 5x minus 5b times the derivative of sine 5x, which is cosine 5x times 5, the derivative of 5x. Now, simplifying this one, we have negative 25a, because 5a times 5, that's 25a, but we have a negative here, so that is negative 25a sine 5x. And then we have negative 5b times 5, so we have negative 25b cosine 5x. So this is our second derivative. You may write as y double prime, or you can write the second derivative of y with respect to x here. Now that we have the second derivative, we can substitute this one to the given differential equation. So substituting the second derivative of y with respect to x, we have the differential equation, which is the second derivative of y with respect to x plus 25y, which is equal to 0. And we know this one, which is this one. So we write it here, negative 25a sine 5x, and then minus 25b cosine 5x. And this is the value of our second derivative of y with respect to x. So added to 25 here times y, and our y is this, so we have a sine 5x plus b cosine 5x, and the whole thing is equated to 0. So simplifying further, we have negative 25a sine 5x minus 25b cosine 5x plus 25a sine 5x, because if you multiply 25 to this term, you will have this one. and then multiply 25 to the second term, we have plus 25b cosine 5x, and the whole thing is equated to 0. And you see that this one and this one cancels each other, and so with this one cancels with this one. Now what will remain is just 0. So we have shown that this is an identity. Thus we say here that the function y equals a sine 5x plus b cosine 5x is a general solution to the differential equation second derivative of y with respect to x plus 25y is equal to 0. So at this point, allow me to give a third example here. Show that the natural log of y plus x over y, which is equal to 4, is a solution to the differential equation the quantity y minus x times y prime plus y is equal to 0. Now, looking at this differential equation is written implicitly, and our solution is also an implicit function. So how do we show that this implicit function is a solution to this differential equation? To show is to solve first the first derivative of y with respect to x, or simply the y prime. But this function is an implicit function, so we will use implicit differentiation. So what is the derivative of L and y? The derivative we learned from your previous calculus is y prime over y. And what is the derivative of x over y? The derivative of this x over y with respect to x is using the quotient rule. So what is the quotient rule? We square the denominator and we multiply the denominator by the derivative of the numerator, which is 1. And then we subtract this one by the numerator times the derivative of the denominator, which is y prime, because this is solving for the derivative of y with respect to x. And this is equated to 0 because the derivative of 4 is 0, because 4 is a constant. So this is using your knowledge from your previous calculus, implicit differentiation. So simplifying this one, we have y prime over y plus y minus x y prime over y squared, which is equal to 0. Now, combining these two terms is to look for their LCD, and LCD is y squared. So y squared divided by y, that's y. So this is y times y prime. And then y squared divided by y squared, that's 1. And 1 times the numerator, we have y minus x y prime. And this is equated to 0. Now, multiplying both sides of this equation by y squared, we have y prime plus y minus x y prime is equal to 0, because this y squared, when multiplied to 0, that is 0. And then factoring out the common, which is y prime here for these two terms, we have y prime times y minus x. And this is equated to negative y if you subtract both sides of the equation by y. So the y at the left will be cancelled, but we have a negative y at the right. So therefore, our y prime is equal to negative y over y minus x. And substituting this y prime to the given differential equation, we have y minus x times our y prime, because here we have y prime and our y prime is negative y over y minus x, and this is added to y, and which is equated to 0. So you can see that this factor and this factor can be cancelled. So we have negative y plus y, and negative y plus y is 0. So we were able to show that this is an identity. Therefore, we say that the natural log of y plus x over y, which is equal to 4, is a particular solution to the given differential equation y minus x times y prime plus y is equal to 0. And maybe you will ask, why is this called a particular solution? And in our first two examples, this is a general solution. These solutions are called general solutions to the given differential equations because the solutions involve arbitrary constants. In this case, we have c sub 1 and c sub 2. And in the second example, we have a and b. So these are arbitrary constants in our solution to the given differential equation. That is why these are called as general solutions to the given differential equations. However, this one has no arbitrary constants. So therefore, this is called a particular solution to the given differential equation. And that's it. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.